EMU, enhancing image generation models, using photogenic needles in a haystack. Training text-to-image models with web-scale image-text pairs enables the generation of a wide range of visual concepts from text. However, these pre-trained models often face challenges when it comes to generating highly aesthetic images. This creates the need for aesthetic alignment post-pre-training. In this paper, we propose quality tuning to effectively guide a pre-trained model to exclusively generate highly visually appealing images, while maintaining generality across visual concepts. Our key insight is that supervised fine-tuning, with a set of surprisingly small but extremely visually appealing images, can significantly improve the generation quality. We pre-train a latent diffusion model on 1.1 billion image-text pairs, and fine-tune it with only a few thousand carefully selected high-quality images. The resulting model, EMU, achieves a win rate of 82.9% compared with its pre-trained only counterpart. Compared to the state-of-the-art SDXL V1, 0, EMU is preferred 68.4% and 71.3% of the time on visual appeal on the standard party prompts and our open user input benchmark based on the real-world usage of text-to-image models. In addition, we show that quality tuning is a generic approach that is also effective for other architectures, including pixel diffusion and masked generative transformer models. Show 1. Marrying pixel and latent diffusion models for text-to-video generation. Significant advancements have been achieved in the realm of large-scale pre-trained text-to-video diffusion models, VDMs. However, previous methods either rely solely on pixel-based VDMs, which come with high computational costs, or on latent-based VDMs, which often struggle with precise text-video alignment. In this paper, we are the first to propose a hybrid model, dubbed as Show 1, which marries pixel-based and latent-based VDMs for text-to-video generation. Our model first uses pixel-based VDMs to produce a low-resolution video of strong text-video correlation. After that, we propose a novel expert translation method that employs the latent-based VDMs to further upsample the low-resolution video to high resolution. Compared to latent VDMs, Show 1 can produce high-quality videos of precise text-video alignment. Compared to pixel VDMs, Show 1 is much more efficient. GPU memory usage during inference is 15G versus 72G. We also validate our model on standard video generation benchmarks. Our code and model weights are publicly available at the project's website. Finite scalar quantization, VQ-VAE made simple. We propose to replace vector quantization, VQ, in the latent representation of VQ-VAEs with a simple scheme termed finite scalar quantization, FSQ, where we project the VAE representation down to a few dimensions, typically less than 10. Each dimension is quantized to a small set of fixed values, leading to an implicit codebook given by the product of these sets. By appropriately choosing the number of dimensions and values each dimension can take, we obtain the same codebook size as in VQ. On top of such discrete representations, we can train the same models that have been trained on VQ-VAE representations. For example, autoregressive and masked transformer models for image generation, multimodal generation, and dense prediction computer vision tasks. Concretely, we employ FSQ with MaskIt for image generation and with UVIM for depth estimation, colorization, and panoptic segmentation. Despite the much simpler design of FSQ, we obtain competitive performance in all these tasks. We emphasize that FSQ does not suffer from codebook collapse and does not need the complex machinery employed in VQ, commitment losses, codebook reseeding, code splitting, entropy penalties, etc., to learn expressive discrete representations. Low-rank adaptation of large language model, rescoring for parameter-efficient speech recognition. We propose a neural language modeling system based on low-rank adaptation, LoRa, for speech recognition output rescoring. Although pre-trained language models, LMs like BERT, have shown superior performance in second-pass rescoring, the high computational cost of scaling up the pre-training stage and adapting the pre-trained models to specific domains limit their practical use in rescoring. Here we present a method based on low-rank decomposition to train a Rescoring BERT model and adapt it to new domains using only a fraction, 0.08%, of the pre-trained parameters. These inserted matrices are optimized through a discriminative training objective along with a correlation-based regularization loss. The proposed low-rank adaptation Rescore BERT LORB architecture is evaluated on library speech and internal datasets with decreased training times by factors between 5.4 and 3.6. The NeuRBF, a neural fields representation with adaptive radial basis functions. We present a novel type of neural fields that uses general radial bases for signal representation. State-of-the-art neural fields typically rely on grid-based representations for storing local neural features and n-dimensional linear kernels for interpolating features at continuous query points. The spatial positions of their neural features are fixed on grid nodes and cannot well adapt to target signals. Our method instead builds upon general radial bases with flexible kernel position and shape, which have higher spatial adaptivity and can more closely fit target signals. To further improve the channel-wise capacity of radial basis functions, we propose to compose them with multi-frequency sinusoid functions. This technique extends a radial basis to multiple Fourier radial bases of different frequency bands without requiring extra parameters, facilitating the representation of details. Moreover, by marrying adaptive radial bases with grid-based ones, our hybrid combination inherits both adaptivity and interpolation smoothness. We carefully designed weighting schemes to let radial bases adapt to different types of signals effectively. Our experiments on 2D image and 3D signed distance field representation demonstrate the higher accuracy and compactness of our method than prior arts. When applied to neural radiance field reconstruction, our method achieves state-of-the-art rendering quality, with small model size and comparable training speed. DECO, dense estimation of 3D human scene contact in the wild. Understanding how humans use physical contact to interact with the world is key to enabling human-centric artificial intelligence. While inferring 3D contact is crucial for modeling realistic and physically plausible human-object interactions, existing methods either focus on 2D, consider body joints rather than the surface, use coarse 3D body regions, or do not generalize to in-the-wild images. In contrast, we focus on inferring dense 3D contact between the full body surface and objects in arbitrary images. To achieve this, we first collect daemon, a new dataset containing dense vertex-level contact annotations, paired with RGB images containing complex human object and human scene contact. Second, we train DECO, a novel 3D contact detector that uses both body part-driven and scene context-driven attention to estimate vertex-level contact on the SMPL body. DECO builds on the insight that human observers recognize contact by reasoning about the contacting body parts, their proximity to scene objects, and the surrounding scene context. We perform extensive evaluations of our detector on daemon, as well as on the rich and behave datasets. We significantly outperform existing state-of-the-art SOTA methods across all benchmarks. We also show qualitatively that DECO generalizes well to diverse and challenging real-world human interactions in natural images. The code, data, and models are available at the project's website. Evaluating cognitive maps and planning in large language models with CogEval. Recently, an influx of studies claim emergent cognitive abilities in large language models, LLMs. Yet most rely on anecdotes, overlook contamination of training sets, or lack systematic evaluation involving multiple tasks, control conditions, multiple iterations, and statistical robustness tests. Here we make two major contributions. First, we propose CogEval, a cognitive science-inspired protocol for the systematic evaluation of cognitive capacities in large language models. The CogEval protocol can be followed for the evaluation of various abilities. Second, here we follow CogEval to systematically evaluate cognitive maps and planning ability across 8 LLMs, OpenAI GPT-4, GPT 3.5, Turbo 175B, DaVinci 003 175B, Google Bard Cohere X Large 52, 4B, Anthropic Claude 152B, Llama 13B, and Alpaca 7B. We base our task prompts on human experiments, which offer both established construct validity for evaluating planning and are absent from LLM training sets. We find that, while LLMs show apparent competence in a few planning tasks with simpler structures, systematic evaluation reveals striking failure modes in planning tasks, including hallucinations of invalid trajectories and getting trapped in loops. These findings do not support the idea of emergent out-of-the-box planning ability in LLMs. This could be because LLMs do not understand the latent relational structures underlying planning problems known as cognitive maps and fail at unrolling goal-directed trajectories based on the underlying structure. Implications for application and future directions are discussed. Jointly training large autoregressive multimodal models. In recent years, advances in the large-scale pre-training of language and text-to-image models have revolutionized the field of machine learning. Yet, integrating these two modalities into a single, robust model, capable of generating seamless multimodal outputs, remains a significant challenge. To address this gap, we present the Joint Auto-Regressive Mixture (JAM) framework, a modular approach that systematically fuses existing text and image generation models. We also introduce a specialized data-efficient instruction tuning strategy, tailored for mixed modal generation tasks. Our final instruct-tuned model demonstrates unparalleled performance in generating high-quality multimodal outputs and represents the first model explicitly designed for this purpose. VPA, Fully Test-Time Visual Prompt Adaptation. Textual prompt tuning has demonstrated significant performance improvements in adapting natural language processing models to a variety of downstream tasks by treating hand-engineered prompts as trainable parameters. Inspired by the success of textual prompting, several studies have investigated the efficacy of visual prompt tuning. In this work, we present Visual Prompt Adaptation, VPA, the first framework that generalizes visual prompting with test-time adaptation. VPA introduces a small number of learnable tokens, enabling fully test-time and storage-efficient adaptation without necessitating source domain information. We examine our VPA design under diverse adaptation settings, encompassing single-image, batched image, and pseudo-label adaptation. We evaluate VPA on multiple tasks, including out-of-distribution, OUD generalization, corruption robustness, and domain adaptation. Experimental results reveal that VPA effectively enhances OUD generalization by 3.3% across various models, surpassing previous test-time approaches. Furthermore, we show that VPA improves corruption robustness by 6.5% compared to strong baselines. Finally, we demonstrate that VPA also boosts domain adaptation performance by relatively 5.2%. Our VPA also exhibits marked effectiveness in improving the robustness of zero-shot recognition for vision language models.